Our next panel is addressing what's in the name, LLMs. There's large language models, but do they need to be large? Does the size really matter? We're going to be talking about small language models and on-device compute. And I'll be passing this on to our moderator for this, Santanu from the MIT Media Lab, to introduce the topic and the panelists. Thank you.
All right, let's get started, and maybe that will start filling up the seats quickly. As Nico said that the large language models, how many of you have heard of large language models? Good. You're in for a good conversation. How many of you heard of the SLM, the small language models? Great, you are ahead of the others. Now with that, let me introduce to us to our team. Let's start with you, Ryan.
Hey everyone, and everyone in the back who's talking. How you guys doing? I'm Andriy. I'm one of the co-founders at Nomic AI. At Nomic, we build accessible and explainable AI systems, and we're on a mission to basically put AI into the hands of everyone who could possibly benefit from it. So our product, GPT for All, lets people run on-edge language models. So this is without the internet, completely air-gapped on the workstations of basically every company in the world. So we focus a lot and think a lot about how do we make AI systems, RAG systems, retrieval systems, language models run in the most constrained environments possible and benefit the most people as possible.
And to you, Brian.
Hey everybody, Brian Benedict. I'm one of the co-founders of Arcee. We build small language models using very specific post-training techniques. Our entire approach is really predicated around ownership for companies to actually own their models in their own environments.
All right. Thank you, Audrey and Brian. Let's start with the first question. Everyone talks about LLM, everyone talks about SLM. Some people talk about SLM. In your mind, and both of you, where does it start? What's the boundaries of SLM? It's where the boundaries of LLM start, and how do you define it? Is it by device? Is it by size? Is it by training? What's the parameter?
Okay, so I guess 5 years ago, when somebody said language model, they were called language models back then. People were talking about 100 million to 300 parameter transformers, purely encoders without sort of decoder masks when they're going in and doing inference. These systems quickly evolved into much larger ones, right? And then you had multi-billion parameter models people were working with, and that was considered state of the art. And then instantly ChatGPT comes around, and it's normal to have 50 to 100 billion parameter models all around. Small language models, I think the phrase really refers to models that can run on one device, one GPU. This allows for things like actual economic deployment of these models, but also real evaluation and standardized evaluation. It's a language model that you can actually own and run yourself. That's my definition.
And Brian, according to you, the same one GPU?
Yeah, I think Andriy kind of nailed it. When we think of them at Arcee, we kind of look at small language models in terms of how our clients are also dictating and thinking about it. Typically, when we are building them for clients, it's typically a 7 billion to 70 is kind of the range in which we typically would define as a small language model. But, I guess if you're going mobile like Nomic does, I'd call them tiny language models if you're 3 billion.
I think they'd be offended.
Perfect. And just before this conversation started, we were catching up in the other room, right? And having a great conversation about the conversation we're going to have now. What are some of the things that you're seeing from your clients? What are some of the trends you're seeing around SLM? Why would your clients, given that these are small models, these are sort of on-device, air-gapped, and so on, what are the reasons some of your clients will use this model? What are the use cases? Brian, I would start with you.
Yeah, I think for the small sizing, a lot of companies come to us that have used closed source models like ChatGPT or Anthropic and have said, hey, I want to productionalize this. I have my own data and I want to do this in my own environment. I can't afford to let this data leak. I can't afford to have this data outside. And I want to build something domain specific. I don't need French poetry and rap music when I'm building a medical claims processing model. It just doesn't make sense. It's not really needed. So really, the focus really for them is how do I build something in my own environment that I can own and that I can just take there. And what we're seeing is obviously performance increases. We're seeing accuracy increases. Obviously, we benchmark the heck out of these against what they're currently doing and what they weren't doing. So that's what we typically are seeing in a market. But the use cases are now sprawling from internal knowledge bases all the way into, external client-facing applications across the board. I just had a recent client come to us. I thought it was probably one of the most unique use cases I've seen in a long time. they are actually taking all of the municipalities' public transcripts, downloading them in major cities, and then selling them to giant like general contractors to let them know of new projects that are coming up and available in giant cities. So there's a lot of just creative use cases that are coming about on the SLM side.
Yeah, I'd say the biggest line you could draw between like, hey, why doesn't every company in the world just go buy a ChatGPT Enterprise subscription or something like this, and why would they even consider a small language model as something they would purchase, is mainly on the privacy and sort of ownership of the actual data and the model outputs that you get. That's kind of the line you draw. And then there's like a giant range of different considerations for why they'd go in, for instance, purchase one over the other, right? What are they actually trying to do? If your goal is to create some sort of system internally that can be hit by a bunch of different applications, a developer API internally, right, for language models that are private, there's one set of options there. If your goal is to solve like task-specific problems that maybe a persona at your job might have, for instance, you have a bunch of employees that you're training up and they constantly need to be able to reference thousands of pages of documents to do their job, right? That's a very, very constrained way to use a language model that's specific to a task versus some sort of general purpose API you want to develop at your company. One thing that we specialize in, specifically when we're thinking about on-edge deployment of models, it's the very, very security conscious, the applications where you need utter privacy that can't be risked, where there's no risk of data leakage. Things like working with government-specific applications. One of our customers, what they do is they're the fabricators of the machines that make the chips, that make the GPUs that go into like every single machine in the world. If their specs leak out to companies like OpenAI or Anthropic, those people become competitors to them, so they would never use their services. And we offer one of the only solutions that you can instantly go in and deploy on the actual GPU-enabled workstations that can actually accomplish things like local data RAG and this sort of thing. So as privacy constraints increase is when providers of small language models become more important. Yeah.
Great. Talking about the spectrum that you're talking about, right? A few minutes back. Is there a spectrum that you can lay out under specifically to you, where the companies will use the large language model, as you said, connected to their own nuclear power reactors, versus a small language model in the other spectrum, right? What are some of the use cases? Can you foresee the same company, take one, healthcare company, right? Or a bank. I used to work for a bank. Would they use all of them, some of them, specific to use cases, specific to the outcome they're looking for? What exactly do you think is the spectrum looks like, and how do you lay it out for the audience?
Yeah, that's a good question. We were all sitting in a room about 10 minutes before this talking about some of these questions, and then I said the word nuclear reactor, and he just looked at me like, what? So like the way I would have a mental model of how the world plays out in the next 10 years is that you have these foundation model, frontier model companies that are investing more and more resources to more compute, more training data, more iteration on that training data. They're going to end up with models that are excellent at very, very complicated, very, very difficult tasks, where the capability improvements will only happen for some subsets of like very, very strong knowledge workers. Those models, general purpose, gigantic, you're gonna have to have them in a data center that's plugged into a nuclear reactor to be able to work. And that's not just like a hypothesis. If you go look on Amazon's public reports, they're buying nuclear reactors. And this is where I think the OpenAI and the Anthropic models in the world kind of end up. As you get models that are smaller, maybe you can run them on a single DGX, so 8 GPUs, single node, or maybe you run it on less capable machines. Those models, the reason you even care about them is because, hey, they're actually sufficient to solve the majority of business problems that exist out there. Like Brian said, you don't need a model that knows rap and knows French if you care about medical reporting or something like this. That area, I think there's a lot of interesting problems to solve. There's a lot of business to actually be made there. This is why companies like Brian and ours exist. And more importantly, that's where the actual real impact happens. Like we might look at OpenAI's most recent model release, right, where they, get the 100x inference costs to be able to get like a small improvement in specific domains like PhD level math or algorithm related questions, multi-step reasoning problems, right? The amount of compute that goes into that is just going to be impossible to actually apply when you're trying to solve a simple business problem, like going in and doing retrieval and search over top of like reports or like summarizing some sort of like medical text, even though you need the sort of privacy constraints that exist there. So as you go down the level of as you go down the range of privacy, as you go down the range of capability, there's going to be players and actors that kind of fill the role there. Where I see we fit in is frankly that every single computer in the world will have some semblance of a language model. Right next to my apartment here in New York, I have a big banner that says Apple Intelligence on it, even though you can't use it in the EU or a bunch of other places in the world, and all it can do is summarize your text messages. This is the start. We have a lot more to go. Every single company that purchases a laptop is going to have a GPU or a hardware accelerator in it. Our mission is to be able to put a language model on all of those and actually have them be useful to people. That's where we fit in.
All right. That's a fantastic summarization of your mission statement. Brian, I'll switch to you now. So, Andriy talked about giant esoteric problems tied to nuclear reactors, and I'll never forget that definition, right? I will use that as a definition for LLM going forward. Something that will need its own nuclear reactor 5 years from now is an LLM. That's it, right?
Don't spend time researching if it's not on those problems.
Exactly. And then, Brian, in your case, right? What are some of the specific use cases that you're seeing from, and as you said, the real client use cases, real customer use cases are a lot of times the SLMs. What are some of the use cases you are seeing, Brian?
There hasn't been like a ton of commonality. I think Andriy kind of nailed it on its head, where there is like knowledge base and just finding information. There's coding and better coding instructions that are happening out there. One kind of interesting use case that we have seen it kind of evolve amongst different companies from different industries is really around matchmaking and the ability of actually taking like different personnel at large organizations and finding them, as well as taking external networks of people and finding them within certain aspects of client consulting and client roles. So we're definitely seeing kind of the ability of taking some of these really hellish manual tasks that are out there and trying to really just streamline these processes much more efficiently. I think the big trend this year has been more client-facing applications that we're seeing versus probably last year everything was more internal knowledge base focused. So those are some of the things. But I do agree with Andriy. I think I look at language models in general as a diversified portfolio. I don't think any company is going to just say, oh, I have just all specialized SLMs and only those working across the organization. I think there's going to be a fair amount of LLMs, SLMs, task-specific, domain-specific, language-specific things that are happening across an organization as they grow, because there isn't a one-size-fits-all. And I think when we think of the future as well, we think of every person having their own personal SLM. Dictated around your own personal data. That's the way, at least, we kind of see the world.
Are there corporate functions very specifically that are suited for SLM versus others? So, for example, is there enough in the legal function where you need to maintain your data internally, maintain your data secrecy, or in HR, the same thing, where you can just say, hey, that space is going to be dominated by SLM because it just doesn't make sense to do LLMs. I can think of very naively about two areas, HR or legal, but are there other areas? Customer functions, would they be on SLM? Would you have a situation where a lot of the customer contact centers, the question and answers and so on, because the number of records are limited, right? You don't have 20 million questions, right, that your customers ask. Are there consumer functions? Are there corporate functions that will get specialized just purely based on SLM, and SLMs will have a strong foothold going forward?
I would say legal is probably maybe a place where you wouldn't want to use an SLM because what you actually want is the ability to go in and have zero hallucination capabilities over top of really, really important problems that are tied to like $50 million deals or $50 million contracts. In that case, okay, it's fine to spend $500 per query into something like GPT-01 because the value there it actually exists, right? But on the flip side of that, when the value doesn't exist, but you can still use the technology to increase some efficiency, right? Then you're willing to actually take that trade-off in performance capability, in performance, and also in cost, right? So I think I would think of it more from like where is the value coming to the end user as opposed to what's the org internally. And every single org is going to have the high value problems and the low value problems that are still capable of being enhanced with LLMs.
Yeah, I mean, I would actually agree with that. I think one of the interesting parts in components, if you had to look at departmental, we're seeing a lot of innovation teams trying to like use this as almost like white space innovation using SLMs, which I don't necessarily agree with, because I do think actually like more of a general LLM is better use of not kind of being as specific of domain or as specific of specifics to do. So like I think there are actual cases where I think a large language model like that might be a better suitor as well. So
Right.
yeah.
Great, great. So one of the things that ChatGPT did, right, when it came out in, was it 2022 October or so, ChatGPT 3? It feels like years ago, right? Or eons ago. It sort of democratized sort of the access of very strong foundational models in the hand of consumers. Is keep making building SLMs that can run on devices on the edge. Is it going to do the same thing in a few years from now? Because right now SLM is not a term that everyone knows about. You don't see people using SLMs on their phones. Is this something that you see changing in the next few years?
I mean, I think the term accessibility is really overloaded. It's tied to like the background of what are you making more accessible and easy to use. I think you're exactly right. Like my grandmother can go in and type a query into ChatGPT and get a response from an AI. And 4 years ago, she would have had to go spin up a NVIDIA Triton inference server and load a bunch of Onyx model weights into it and like run a query via the terrible Triton API. That's not the case anymore, right? When it comes to accessibility, at least the way I look at it, is how do we enable the most amount of people possible in the most amount of hardware configurations possible to have access to the tech. Not everyone can afford a several $1,000 NVIDIA GPU. Not everyone can afford to pay $1 an hour to run a language model on a dedicated server when you're going to query that model 1 time a day, maybe, or 2 times a day, or 1 time an hour. We optimize for that sort of form factor when it comes to language models. What are the problems that exist right now? Frankly, if you look around you, all of you have laptops. How many of your laptops have a GPU in them? Yeah, probably not many. Unless you have a MacBook, then it's great. You should talk to us. When it comes to companies, they all have older computers usually, and only some departments and some orgs actually have computers that are actually capable of running language models that are useful, 8 billion parameter plus, when it comes to like general purpose tasks. Those are the kind of problems that we see every day out there when we talk to companies. One of my first questions is just like, what are your hardware configurations before even like having a conversation around like, can we solve your problems? These kind of things become really important, but they're also going to get solved through time, right? Corporate buyers are going to start having decisions when they come. The decisions they're going to start making when they buy hardware is like, is our hardware AI ready, right? Can the hardware run actually AI models on it? And like, if you buy MacBooks, maybe you have an advantage right now. But people who are buying like Snapdragon chips from Qualcomm, they also have an advantage there right now. So there's all these considerations that come into it. So as with any market, it's going to grow over time, and it's cool to be at the beginning of it. Yeah.
So Brian, I'll go back to you now. Name one cool application you have seen among all your customers, right, that you would not have thought of before, before going to that customer that uses SLM.
All right, I definitely got one of those. So this one company is a buyer of web domains, and they came to us and they wanted to load up all of the web domains that they possibly have, and they wanted to actually see, using reasoning and prediction, which are the ones in which they should actually be buying next. And I thought that was a really cool application to actually utilize, and they've actually done a lot of buys based on this, speculative buys based on using that. And so never thought that someone would actually come in and want to, do something like that in terms of using it up. I think the other one was the municipality I talked about earlier too. But there's been a lot of creative like usage for SLMs, looking at specific domains and specific stuff like that. So, but yeah, I thought that was a really cool one that we were working with a client. Another one that was interesting to me was a company on the education side came to us and wanted to actually build SLMs for teachers to teach English literature. So they would literally take all the different classifications of all the books, and instead of teaching it to a child of like a Cliff Note version, it would actually give lesson plans for the actual teachers of these are the different ways in which you should teach the lesson plan. So a very different, unique aspect of it versus what we're commonly seeing with English books. So yeah, it's a couple of them.
Great. So Andrew, I'll go back to you with a technical questions. What are the 2 or 3 trends that you are seeing in terms of improvements in the technology in the past 6 months? And what do you expect in the next 6 months to a year that will make SLMs far better than they're today in terms of performance/cost, or what I'd call is a coverage, right? They can do better or they can do cheaper.
Yeah. Okay, I'll stick to the SLM one. I wanted to say some stuff about O1 and inference, but I think everyone knows things there and then contrast it. But when it comes to where is the world of like specifically small language model inference and capabilities going. I think what you would need to do is it's actually really easy to find this out yourself by going to actual local model inference libraries like Llama CPP or MLX. These MLX is a library maintained by Apple that writes all the source code that runs Apple Intelligence, for example. Llama CPP is this open source project that actually Nomic contributes to as well. It's the largest project for getting models, quantized language models running on like arbitrary devices, so arbitrary GPUs, arbitrary hardware types. The thing, the pattern and trend you'd see in those sort of open source repositories that have literally hundreds of people building in the space and innovating in the space is anytime a new model comes out, everyone instantly goes in and says, hey, like what operations in this model aren't supported in this library, and they go in and implement it. So new model support is really, really huge. Somebody releases a new model, get it working in the small language model. That's a constant factor. But what direction is, I think, the money coming from? A lot of companies out there are actually starting to work with these open source repositories and give them funding to write bespoke GPU backends that work with their hardware. For example, I know ARM has offered money to people such that better ARM support starts existing in these libraries, for instance. That's kind of like on the inference capability side, right? I think there's a lot of outstanding and open questions when it comes to model quantization. So to actually be able to get a large language model running on like a single hardware device or an even lower like sort of hardware configurations, you have to put them through this process called quantization, which basically takes every single weight of the model and makes it a little bit less precise, but it turns out you don't lose that much performance in the model when you do so. Those methods right now, usually they happen post-training. So you take the model weights and you go in and quantize them and you lose some performance. There's a lot of techniques being investigated right now that allow for training time quantization to occur, so training aware quantization. There's improvements there, basically like permeate down all possible applications because you do things like reduce downstream, like error percentage, hallucinations, and all of this. All that kind of stuff's happening from the applied research world, and obviously like all the stuff I talked about happening at the inference kernel world. There's like monetary things coming into play with like larger companies, but in general, the walk really is towards accessibility in the space, right? The whole value proposition of small models is that there's more use cases where you can actually use language models with that previously you couldn't use if you were stuck hitting the OpenAI API. So when you think about it, like what's next, the direction and the vector you should be thinking about is that what's next is going to be what's going to make these systems more accessible to everyone.
All right. Brian, if I ask you the question, what's next for Arcee and your customers, what would your answer be?
Yeah, I mean, I think, for us, right, we've been kind of, building small language models. We're now starting to put out our own models themselves. We launched Supernova last week, which was a very high performant instruction following SLM. And we're using these models now to merge with customer data. So we've always been open source, kind of pro. So we've been using open source models for many of our builds, but now we're also coming up with these very specific verticalized models too, as well as general models. So we think a lot of our clients are kind of falling into very specific, industries and verticals: healthcare, financial services, retail. So we think we're going to continually try to get closer to the clients by getting closer with these models to their actual problem sets and to their data sets and to the things that they really care about. And we think that's kind of a path forward for a lot of the companies that we see.
So great. Let's switch the context a little bit. I spent 20 years of my life in the United States, then flipped back to the emerging world, went back to India for some time, and really to work on AI to solve problems that are sort of local, that the Western world does not work on. So right now, if you look at the world of AI, there are three models, right? There's a US model, which is a bit chaotic, tons of money and tons of compute. China, very, very centralized, lots of money and lots of compute. And then there's a third model, which is, doesn't exist today, without which a lot of the smaller countries or the countries that are outside these two countries, right, would not be able to develop their AI infrastructure. From where you sit, Brian, today, do you think SLM is the way to go? For example, we are talking about it. Would UAE or Australia build their own SLM or LLM, you call it? And would that be something that will solve the local context issue, right? Which is the local data, local languages, local regulation, all of that stuff. You have had some experience and some fantastic conversations around it.
Yeah, I mean, we built a model in Arabic called Mirage. We launched it about like 3 or 4 weeks ago to really, help within that confines of open source within that region, and we're doing that within Korea and some other languages as well. I do think the challenge has always been where, in terms of like accessibility of data and making sure that there isn't, like, you pointed out quite candidly that there are some dialects in which there isn't as much written documentation to actually build. So is that really going to be the biggest kind of challenge in some of those other areas as well? But I think it's great. You're starting to see a lot of regional models come out, which could be really impactful to that specific area of focus. Like Australia just released one with a company out there called Catonic. They released an LLM all around the Australian point of view there. So you see like Sakana in Japan, you're seeing kind of more and more of these come out. So I'm curious to see how these models do benchmark against general models that are outside of their region, and if there really is that much of a difference in terms of what's out there. But yeah, I guess time will tell.
Great. Andriy, do you have any thoughts around that?
One thing I'll say, I saw their Arabic model release. It was really cool. I found that awesome. So I work with this one company based out of SF. They're trying to build a language model for specifically Ukrainian. And there's like all these problems that emerge whenever you take a lower resource language and you try to adapt an existing sort of language. Like they're fine tuning their post training models to be better at Ukrainian. Basically, they're not training from scratch. And there's all these problems that emerge specifically around code switching. So when you have languages that are very, very similar to each other, so like Cyrillic, there might be like a couple dozen countries in the world that have their different dialects of Cyrillic, Russian being the major one that exists out there on the internet. Anytime you go in, and this is a problem that they had to solve, anytime you go in and try to train a model to specifically do well in some sort of eval that is Ukrainian specific, the model always just switches to Russian. So their whole problem the first like 6 months was like solve code switching. Like you ask the model what country owns Crimea, right? Since the majority of language in the world is Russian, it would actually respond that way. And they're working with the Ukrainian government to like give them a language model. Obviously, this is like a non-ideal output to give. And when it comes to like localization of these models, the fact that English is just like by several orders of magnitude the predominant source of web text that goes into these systems, you run into these super, super niche problems that don't even like start getting into the realms of model evaluations. Most model evaluations are in English. They're working and doing things like translating all the evals into a different language, but even then, like, translations aren't accurate. Those benchmarks are not independent, they're not well vetted. There's a million of problems that emerge when you try to go in and localize a language model to a low resource language. And then there's like literally whole companies set up around like doing this really well for one language and actually succeeding there. And it's not as simple as you'd think. When rubber hits the road, these systems perform really, really poorly and usually defer to English languages. So that's a really, really big. Like, if you're interested in like starting a company in the space, like pick a country that has a lot of value and go in and try to solve that problem there. There's a lot of bespoke things you have to do, even like Cyrillic to English, or like English to Arabic, or English to Indian that aren't shared the same between languages.
All right. When you started, that's a very interesting perspective. If you really want to go start a startup, and from the people who are sitting in this room, this is one area where you should look at. I mean, as I said, when I went back to India, one of the things that I found that rather than being a data scientist, which I was in the United States, I was actually playing the role of a data detective. I had to actually spend a lot of time trying to understand what the data means before I could actually use the data, right? For example, one of the great challenges was address. The way address is written in the United States, my house in Texas always pinpoints to one dot when you say that address, right? In India, the addresses are written in next to the Shiva temple, behind the Domino's Pizza, the third house from the right, and go and ask the neighbor. That does not have any correlation in the Western context, right? And it's not only India. When I did that talk, I think in Davos in World Economic Forum, someone from the audience came up saying that, can I get your model? Because that's exactly the way I describe things in Indonesia. So we almost end up doing India as quote unquote a template country, which is if you can solve for, for example, in this specific case, addressing in India, you can actually solve for most of the emerging markets, 80, 90 countries. And for, and for the record, if anyone has been to India and seen how the country drives, if you can make a self-driving car that works in India, it can work anywhere in the world. I can guarantee you, right? Rule number one: if you see a cow on the road, stop, right? Do not try to do anything. If you see a person on the road, drive slowly, right? So that they'll move. The cow would not move, the person will. So the context is important. I'm trying to make it humorous, trying to exaggerate, but the context is extremely, extremely important. Now let's do a tiebreaker last question sort of before we take something from the audience. When I did the poll in the beginning, about a third, maybe half the people said they have heard of LLMs. Less than 20% said they knew about the SLM. So if you have to turn this around next time when you do this in New York and get half the audience to say they have heard of SLM, tell me 2 or 3 good reasons why they should focus on the space of LLM. And Brian, I'll start with you and be watching this space.
What to be watching in the SLM space? Is that what you're saying? I think.
Why? I mean, okay, let me take an extreme position. Why shouldn't SLM just die away? Other than say that you guys, both of your company, depends on that. Why shouldn't SLM just die away? Why should everything be tied to a nuclear power station and just be solved that way?
He's never going to get.
He's never
going to get over that, Andriy. Like you've planted that in his head.
Senior grants.
I think you're even seeing it from a lot of the companies that are building models, even foundational models today. Why are they putting out a small language model on top of their larger interface ones? I think, as we think of companies, and I think one of the things that I see a lot of, especially within organizations we work with, is, they have a lot of data. They don't have a lot of data that's actually really great for building models. So even though we say small language models and we say, oh, all these companies must have so much data for doing this. I'm stunned at trying to get 1 billion tokens out of some of the companies that we work with today, which is like 4 gigs. And so I do believe that companies are going to get better and better at collecting data and building these different things. But I also believe that they're realizing that the cost differences on some of these are really going to be massive in terms of why they would rather use an SLM. And I think cost eventually is going to rear its head at a lot of these companies as they continue to look at alternatives to just LLMs. So that's my take.
And Andriy, I'll ask you a trick question, on which there are only 2 answers: a bad answer or a worse answer. If the companies are spending time doing one thing, either data or the model, because everyone. So when I was running in the chief technologist for a bank, I had limited budget. If I had to focus on one thing, should I spend more time on the data? Should I spend more time on the model? Your answer is going to be both, but I don't want you to give that answer.
No, that's not my answer at all. I thought the answer was already obvious. Who thinks it's data? Who thinks it's the model? Raise your hand. Data? Who thinks it's the model? Yeah, obviously. It's data. Just as Brian was saying, he struggles to get 1 billion tokens out of some of these companies. You don't need 1 billion tokens if you have a high-quality, small data set that actually aligns to what you're trying to do. It's 100% data. You're even seeing this with what OpenAI is doing right now, right? The trend right now is that you don't have to do, the best place to allocate your compute budget is not gigantic, inference, rather training clusters to train a larger, bigger model. You can squeeze out mountains of capability improvements by piping all the work into the actual recurring inferences. Scale up the inference budget, compute budget. Well, the way you scale up the inference compute budget, it has a lot of post-training data that you created and curated specifically for things like chain of thought, like O1 allows you to do. It's the data 100%.
Fantastic. We had planned for taking a couple of minutes for asking 1 or 2 questions from the audience, but we have about a minute left. If anyone would like to take 1 question, happy to do that. Anyone? There is one. Nico, the mic. Okay. Yeah.
When you're seeing these applications, when you're seeing your deployments of SLMs, do you see the need from customers? I think you kind of touched upon this, that there's not enough data. Is there need to go get external data to train the SLM for the specific use case that the customer is coming to you for?
Sometimes, right? So sometimes there'll be synthetic data that would need to be generated. Sometimes you have some golden QA pairs and it's enough, right, to actually kind of build the model against it, but it really just depends. But yeah, there's been cases where you want to like do some synthetic data injection, of course.
So taking structured data and making it unstructured.
Correct.
I think we are out of time, but Andriy, if you want to take 20 seconds on this, same answer.
I'd roughly give the same answer. Can I give one quick advertisement?
Yep, please.
Okay, we're hosting a New York City embeddings meetup next week. It's like 2 blocks from here on 20th Street. You can find it on Twitter. We got like top people coming from Meta and stuff talking about embeddings and the future of embeddings. So,
Great. Anything you want to say, Brian? Any quick advertisement? Anything? Last words?
I'm good.
Good.
Nice meeting
All right.
everybody.
Thank you
Yeah.
so much. Thank you so much for being an excellent audience. And thank you both.
thank you.